Thank you. So, welcome to this month's No session on talking about stir shaken. Just a quick agenda for today. Let's see, there we go. Donald is going to talk about some recent regulatory industry news, and then I'm going to do a deep dive into authentication. Last month was public key infrastructure. This month will be authentication. And then after that, we're going to kind of leave some time for discussion, questions about stir shaken. Before we get started, just a quick background about TransNexus for those who don't know. TransNexus was founded in 1997. We're a software company. We provide software for stir shaken, of course, robocall prevention, telecom fraud prevention, routing, and a number of other services related to telecom. The presenters today are going to be myself. I'm a software engineer, and then Donald, who's our product marketing manager. Let Donald introduce himself, and at that, I'll hand it over to him to talk about the recent news.
Thank you, Alec. Yes, I look after marketing at TransNexus, and I also follow the news and regulatory happenings in the industry. And there are a few things to cover since we last met to discuss stir shaken. And I'll give you a quick update before we get into the deep dive topic on authentication. So recently, as is required by the Trace Act, the FCC issued a notice of proposed rulemaking for ways to prevent one-ring scams. This was actually written into the Trace Act legislation that was signed into law at the end of December. If you're not familiar, this is, probably everybody on this call is familiar, but this is a scheme where a fraudster sends a one-ring phone call to a bunch of people, and they hear the ring and they wonder who was that, and they get another one and they get another one, and it may be in the middle of the night. So they call back to give the caller a piece of their mind, and they've called an expensive number. And the Trace Act specifically carved out a call for the FCC to combat this. And so in there, we mentioned it here because in their proposed rulemaking, the FCC asked for comments on a number of different aspects about one-ring scam prevention. And one of them is they asked for comments on how stir shaken might be paired with call analytics to combat that. So that's an interesting thing. And in general, we do think that call analytics paired with stir shaken is the most powerful combination, and they're interested in comments from stakeholders. How do you think that will help us combat that? And then just recently, last Friday, comments were due on an FCC order and further notice of proposed rulemaking to implement the Trace Act. And normally when they send out these things, they might get 30, 35 or so sets of comments from interested parties. And they got a bunch this time. They got 46 that we've counted. And there's some really interesting questions raised. We're still going through that and looking for themes, and we've noticed a few that we can share with you here. And then just yesterday, the ADIS, IPN, and I met to continue their discussion about a band shaken. And if you're not familiar, that's a way to send the shaken identity token separately out of band from the originating provider to the terminating provider, so that that it survives transit. Whereas if you put it in the SIP signaling, it may not survive. If it has to cross over a non-IP segment, it won't survive, and the caller and the called party won't get the benefits of stir shaken. So this is under discussion at ADIS, and they just go through all the different facets of this. What about this? What about that? Various use cases, and one of them that they documented was, how would this work for toll-free? So they're going through that, and they have posted notes in the current document that they're working on to describe how this would work. So with that, I'll go over a few themes that we found in the, if you could go to the next slide, thank you. These are a few themes. There are a ton of documents, 46, and some of them are quite lengthy, so there's a lot to go through, but here's a few things we noticed right off the bat. Many of the smaller providers are concerned that, hey, we upgraded our network, we have IP-enabled equipments, but we still can't participate in Stir Shake It, and we're afraid we're going to be shut out. And our customers won't get the benefits of verified calls inbound and having their calls signed outbound, and they're going to get left out. And the reason is, even though we have an IP-enabled network, we have to connect to the PSTN through a tandem switch. And we are given the option in some cases to connect to an IP interconnect, but it's a long way away. It's very expensive to haul my traffic to that meet point. So this came up with a number of different filings and comments and ex partes. A bigger theme before, we've seen this before going back a year or so, people have made this comment, but now it's more, people are jumping on the bandwagon. And in that context, several parties mentioned out-of-band methods, and that's going to be a future deep dive topic. In a couple sessions, we'll go through that as part of this Stir Shake and call. There were also a number of comments that discussed the requirements for access to numbers. You may recall from our last session that there are 3 requirements in order to get a certificate to sign calls. And the third requirement is you have to have access to numbers. And some commenters said, well, some intermediate carriers don't have that, and you're asking them to sign calls. As an intermediate carrier, if it's an unsigned call, they should sign it so we get some traceback, but they can't meet that third requirement, so they can't sign calls. So this doesn't work that way. So there were some suggestions that they should drop that requirement. And there were also just further comments on whether intermediate carriers should or should not. As you may recall from our last meeting, the FCC did not include that in their order. There were 2 parts to the document. The order, what they've already decided to require, then a bunch of what ifs for their notice of proposed rulemaking. What should we do? They said, we think we should ask intermediates to sign calls as well, but we want to have some discussion about that, further discussion. And a number of the commenters weighed in on that. It also, a number of commenters questioned the benefits of the gateway C attestation. They're concerned that there could be a flood of these things. Is that really beneficial? And some felt it may not even be as necessary anymore. The original intent was that it would make traceback easy. So with a C attestation, the organization that signed the call says, I don't know about this customer or their use of that number, but I can at least tell you I put it on the network here if you want to trace it back. And some commenters said, well, there could be a ton of C attestation. Are they really worth it? Is that valuable? Would that flood the network with C? So that was an interesting turn of events and turn of thinking. And then every time there's comments, there are some people who make calls for call centers and businesses and enterprises. They're concerned about overly broad blocking, getting caught up in the analytics trap. And they say, we weighed in again to say, the FCC has to make sure that carriers provide adequate redress mechanisms to say, if my calls got caught in an analytics trap, how can I resolve that? There needs to be a way to do that. And so there were a number of comments about that. And with that, we'll go on.
Thank you, Donald, for that very useful information about all these FCC filings and other recent news. It's a lot going on with Stir Shaken, and it really does change quite regularly. So hopefully get some new information, some new call flows to talk about that next month as well. And with that, I think we'll dive into our deep dive topic, which is going to be shaken authentication. So last call we dove into the PKI, the public key infrastructure used in Stir Shake, and here we're going to dive into the authentication, which is what is done by the originating service provider. Next month we'll look at the verification, which is done by the terminating service provider when they receive a call. I do want to just really quickly, in case anyone missed or forgot our last call, just highlight on the things that are at least important for this topic that we talked about last month, and that is kind of this triangle of trust. So stir shaking is based on this triangle of trust, where certificate authorities issue certificates to telephone service providers, and all of these parties are kind of administered by this governance authority, and the policy administrator, well, they administer the policies set by the governance authority. So the kind of ecosystem is limited in trust using these certificate authorities and telephone service providers, or lists of telephone service providers, I should say. So to make this all work, the first thing before you can actually sign a call, before you can authenticate a call, is you have to have a certificate. And so I discussed this last month, but I want to focus on the kind of thing I didn't really mention as much. So you're, as an originating service provider, you're going to have a key management service. It's going to generate a key pair, which has a public key and a private key pair. And your private key, as the name implies, is meant to be private. Very important that you keep that secure. That's how you're actually going to sign the calls here that we're going to talk about in just a moment. And that public key is what kind of goes through the rest of this process that's sent to other people. The private key is just placed in a secure key store within your network and never leaves that. No one else ever has that private key. And the private key is used to sign a call, and then the public key, which is embedded in the certificate, can be used to verify that call. So now that we've kind of just done that quick overview of the call, the pre-call flow, now we can look a little bit more at the call flow. So as an OSP, an originating service provider, when you receive a call from one of your subscribers, that call is going to get sent up to your authentication service, which is going to sign that call. And it's going to have to contact your secure key store, which is where that private key is stored, and either get the key out of it or request that the secure key store actually do the signing itself of the token that this creates. There's a couple different ways that can end up being deployed, but that key is what's used to create the signature on that token that you're signing. And then that token is what passes through the network and gets verified by the other party. Again, we won't talk much about the verification this call. That'll be for next month. But now, the first thing I want to show this identity header. I can't highlight. I'm actually going to back out of the slide presentation here. There we go. So this is an identity header that would be in a SIP invite. I'll just make this a little bigger. There we go. So this is an identity header that's in a SIP invite, and it's composed of 3 parts, and I'm going to talk about those parts in a little bit more detail, but in a moment. But the 3 parts are right here. You've got the first part, and then a period, the second part, and then the third part here. And those first 2 parts I'm going to talk about in a moment. But this third section here, this is the signature. This is what you create with that private key based on the contents of these first 2 parts, which we'll go into a little bit more. And this is what no one else could create without having your private key, which is kind of where all the cryptography goes. Now, looking at those first 2 sections, they're really kind of the header and the payload, and the payload being the most important. But we'll start with the header. The header is really just kind of metadata. It's information about this token that can be used so that you can verify that token. You need to know, what algorithm was used to generate that signature, which again is the third part of that token. What type of token is it? It's a passport of the shaken type. And then where do you get the certificate to verify this token? That's kind of all this information in that order, where X5U being the location of the certificate repository. And we'll talk more about how that works with the verification deep dive next month. But the payload, this is really the heart of the shaken token. This is what really matters. So the first thing we've got here is an attestation level. And this is what, as a service provider, you are attesting to. There's 3 values, A, B, and C, with A being the highest level of attestation and C being the lowest. Donald kind of touched a little bit about this with the C attestation, and some carriers having opinions about the benefits of C. We're going to talk a lot more detail about those attestation levels here in just a moment. But first, I do want to overview the rest of the fields here. So the next field is this destination number. And the destination number is really pretty simple. It's just the dialed telephone number. It's just used so that someone can't create an identity token for one call, and then a bad guy couldn't take that token and put it on a different call. So it actually has the destination and the origination, the calling number in the token, so that you couldn't put it with a different SIP invite. It prevents you from trying to reuse that token for a different call. And on that same note, there's also a timestamp issued at is what this is. And that is, again, to prevent the reuse of that token for a different call, so that the token is only valid for this calling number, calling that call-ed number at approximately that time. Now, the orig ID is the other piece of information that carriers have a lot of control over. And again, we're going to talk about that a little bit more, but these two pieces of information, the orig ID and the attestation level, are the two pieces of information that carriers get to set, and that you need to identify how you want to set those values. Let me make this big again. Here we go. So now, looking at those attestation values, there's 3 attestation values, A, B, and C. And we'll start with the top, about the requirements that have to be met for you to use those attestation values. And I'll tell you right now, your customers, the enterprises especially, but definitely your consumer customers as well, if you have any, are really going to want the highest level attestation. Because when we start talking about what phones are going to do to display to the call-ed party that this call has been signed, it's going to be very different depending on what attestation level is. An attestation level C is likely not going to result in any positive indicator that says this is for sure a good call, versus an attestation A is likely to result in the best indicator. And B, I'm not sure what that's going to end up looking like. I think that's remains to be seen with what phone manufacturers and what the service providers choose to do on that verification side. But so looking at attestation level A, to sign a call attestation level A, these are the 3 requirements directly out of the standard. So you have to be the originating point for this call on the IP network. So, this is to say that you can't have a call from another carrier that you're receiving and sign that attestation A. You're originating the call. You are the originating service provider. You have to have a direct authenticated relationship with the customer so you can identify the customer, whether that being a hosted PBX scenario where your customer has phones in their office and they're registered to a hosted PBX that you're maintaining, or even a SIP trunk. That is technically would meet that requirement, because this call came from Bank of America, down that Bank of America trunk, let's say. And then the third requirement is you have to have established verified association with the telephone number used for the call. And this is to say you have to know that the customer using that calling number should be using that calling number. And a lot of times that requirement is confused with meaning that you have to own the number as a carrier. That's not what it is saying. It by no means is intending to say that. In fact, the ADIS has set out a very clear policy that says you do not, under any circumstances, have to own the number. And when you're verifying a call, you should not. Actually, you must not check that the calling party that signed it also owns the number, because some carriers implemented that in their networks, and that was not the correct behavior. So if you have a Bank of America, I'll use them back as an example, and they're using a number that you know that they should be using, you can do attestation level A. If you have, let's say, like the big wireless carriers, most of those situations, the handsets actually aren't setting the calling number. That's actually set within the IMS core. So the handsets, register to the network, and when the call leaves, that iPhone or whatever phone it is and goes into their core of their network, it actually sets the calling number there. So there's no way a customer could spoof the number. So those are all, of course, attestation level A. Now, attestation level B is the same first 2 requirements. The difference is that attestation level B, you do not have a verified association that the telephone number is being used. It has been given to that customer, just they don't have authorized use. And so an example is this: let's say you have that relationship with Bank of America. Again, they use their number, that's attestation A, but they use some number that you don't know. And you know who the customer is, that's Bank of America, you have a relationship with them, but they're using a number you didn't give them. You didn't give them, and you don't know where they got it from. They could be spoofing, you're not sure. That's attestation B. Now, again, Bank of America, I'm using an example, but anybody, they're not going to like attestation level B because that's a lower level of indication. So what most enterprises and carriers look like, the way this is kind of going to work, is that you're going to use letter of authorization or some other verification method where, let's say, I'll just use AT&T and Verizon, two big wireless carriers, as an example here. AT&T sells Bank of America a phone number, and Bank of America happens to route that call out Verizon, maybe because it's cheaper, or maybe because their AT&T trunk was down at that moment, whatever the reason may be. They don't want to have that be attestation level B. So Verizon would potentially work something out with Bank of America to verify that Bank of America does in fact, or has been given that number by AT&T, and then Verizon can sign that call A, just like AT&T will sign that call A. And of course, AT&T already knows that Bank of America owns that number, so nothing special is generally needed to do an A-level attestation from the AT&T side. So I just really want to clarify here that you can sign any number attestation A. You do not have to have given it to anybody. It can be a toll-free number. That's a big one that's come up. Whether you're the Resborg that gave it to them or you're not the Resborg, it doesn't matter. But if you sign a call attestation A, you have to have established a verified association with the telephone number that's being used for the call. That's the extent of the detail provided. It's not any more detail, whatever you feel you need to do to meet that requirement. Your regulatory and legal teams are likely the ones who make that decision. But that's very very important here from a shaken perspective. And then attestation C, the one that Donald was talking about a little bit earlier, this is maybe the most confusing attestation level for some, especially recently. So attestation C was really originally designed for the scenario where a call comes in from overseas to a US carrier that is taking it off an international gateway. Common example, let's say AT&T, they're obviously one of the larger carriers from a transit standpoint. They receive a call from some country, let's say the United Kingdom as an example. So United Kingdom sends a call from some carrier in the UK, sends a call to AT&T. AT&T is the first carrier within the shaken ecosystem in the United States. They can sign that call C to say, we're originating the call. We are not responsible for the calling number. We don't know the enterprise that's making the call. All we know is that this call came from this gateway. And you sign it attestation level C, and then that call transits through the network. And the advantage of doing this is it can make trace back quicker, because that call may go from AT&T to 5 other providers before it gets to the final terminating service provider. And I know a lot of work has been done to try and make tracebacks as quick as possible and very efficient and easy. But this is probably still going to be easier no matter what is done in the traceback groups, just because a terminating service provider can just immediately, it's just in the call, knows AT&T received this call. They're who I go ask, where did this call come from? Now, it's not going to get to the source of the call by any means, because it's just going to get to the edge of the United States PSTN network, but it immediately gets to AT&T. You don't have to talk to any other carriers in the middle. And this, of course, also would apply to a non-international call that originated. But the intention there is for the first provider that is part of the shaken ecosystem to do attestation C. Now, a lot of the discussion that's been coming around is, should intermediate providers sign attestation C, where you've got a originating provider within the US, and then you've got an intermediate provider, and then you've got maybe a bunch of other intermediate providers before you finally get to the terminating service provider. Well, the SEC has already made it clear and mandated that the originating service provider sign those calls. And they'll pretty much always sign calls A or B if you're a kind of a retail provider. Now, kind of this idea that the intermediate providers sign C doesn't really exactly fit with the standard. And this is why what kind of Donald mentioned, most of those transit providers, or at least many of the transit providers, are actually not even service providers. In the sense that they don't own numbers, they provide transit service. So they couldn't sign that to C if they want. They're not allowed in the shaken ecosystem. But also, it can be kind of looked at as a little bit of a waste of resources, because if the originating service provider is required to sign an attestation level A, why are you requiring the next hop to sign at C? But I think the reality is that some of the reasons that this is coming up, at least from the FCC perspective, is because not all originating service providers talk to their intermediate providers, those transit providers via SIP. There's a lot of TDM there. And so I think what's really coming down is there's this idea of, well, we'll sign it as soon as we can. And that's where that attestation C comes from. So I'm not sure what's going to end up happening with attestation C. Again, the original idea was a little bit more, edge of the shaken ecosystem, but it's getting changed a little bit. And with kind of all the TDM out there, I'm not sure what's going to happen. And of course, the last thing I will mention, shaken was originally designed to be in the United States. Canada has its own shaken, but other countries are going to implement shaken too. And it looks like the way this is going to work out, and there's a lot of work being done in the ATIS working groups to figure this out, but it looks like each carrier is going to have their own shaken ecosystem within the country, but then there's going to be some information sharing from a certificate standpoint between those countries so that you can utilize the other countries' attestation levels. So a carrier in the UK could actually sign the call, and then it could pass all the way through AT&T. Let's say they take it off, from the ocean, and then goes to the terminating service provider. That terminating service provider might actually verify the call from the UK signature, not an AT&T gateway attestation. Gateway attestation is really the best we can do for certain call flows, so it's there, but the goal should always be to do attestation A or B when possible, because that gives you a sense of who the enterprise is, who the bad guy that's making these calls is, and makes traceback to them much quicker. Now, in addition to the attestation level, as an originating service provider, you can set an origination identifier. And this is intended to be a UUID, which I kind of have an example here of a UUID, and there's a couple different versions of this, but they all look similar to this. That is unique and opaque. It's not intended to supply any information, like to say that this is Bank of America. You wouldn't want your UUID to indicate who the subscriber is or anything like that from a privacy standpoint, so it's intended to be opaque. But it's used really for two purposes, for reputation and for traceback. So reputation systems may start to utilize this and say, okay, I'm seeing a lot of calls that people are marking as spam with this origination identifier. That indicates maybe future calls with this origination identifier are bad, or maybe the inverse. This origination identifier, people are saying anytime I mark a call as these from this origination identifier, if I mark it as spam, if I think it's spam, someone always says, no, that was a false positive. That might play into it as well. So it can be used for both positive and negative reputation, as well as for traceback. The idea being a terminating service provider gets a call, the subscriber says, this is a spam call, they're trying to defraud me, pretending to be the IRS, whatever it is that they're trying to do that's bad. And the terminating service provider can go to the originating service provider. Again, they know immediately who the originating service provider is because the OCN is in the certificate, and say, I got a call at this timestamp with this origination ID. This customer's misbehaving, and it makes it very quick for that originating service provider to identify that call. Now, how you set this origination identifier actually varies based on what the attestation level is. So if the attestation level is attestation A, the highest level, the idea is, in general, the carrier is going to use a single identifier or maybe a pool of identifiers for different regions. And really, this is a little bit, kind of most focused on the big wireless providers, where carriers kind of set the number within their network. There's really no spoofing going on because there's no PBXs. It's really pretty simple. So you just use the same origination ID for every call that leaves the big IMS core network. Now that works fine, but when you get into enterprises where you're more likely to have attestation level B, that can be a little bit more complicated. And so this is where you're supposed to say, basically a unique ID per customer. Now you may have a set of unique IDs or UUIDs per customer. Let's say you have 5. Again, I'll go back to Bank of America to give a real world example. Let's say they have 5 offices where they have PBXs, just as an example, and they maybe have a different unique identifier for each office, so that if one office started making a bunch of bad calls and the reputation was bad, then it would only affect that one office. Or from a traceback perspective, it immediately tells you not only that it's Bank of America, but which office at Bank of America. So that there's a couple different options that as a carrier you have. Generally, being more granular can make traceback easier, but is a little bit more to manage, where you have to manage all these UUIDs, the more you have, of course. And then for attestation C, the idea is to identify the gateway. So let's say, again, going back to a real world example, AT&T has 20 gateways that they take international calls in. the recommendations are to have a single identifier per gateway, or you could potentially have multiple identifiers per gateway, but so that you immediately trace back to a specific gateway and not to just any international call. So that's kind of how the origination IDs are intended to be used. They are a little bit more recommendations than requirements, where the attestation values are a little bit more, you must do it this way. Origin IDs, you have quite a bit more flexibility, but in general, you do not want to be more broad than what these recommendations are, where you just assign every call the same UUID. Even if it's not necessarily going to get you in trouble, it might have negative impacts on your customer. If one of your customers is making a bunch of spam calls and that UUID is now marked as being a spammer, it affects everybody who has that same UUID. I know I've seen some people who have talked about just using a random UUID for every single call because they don't want reputation systems using that, and they still get the traceback benefits, but they don't allow anybody to use reputation systems. That's a valid approach if you want to do that. I haven't seen anything in the standards to indicate that you're not allowed to do that, but you definitely have some flexibility there. Now, the last thing I want to talk about is just a little bit about what the integration looks like and how you take some network and start signing calls with that network. And this is going to be generally a big simplification of what a network looks like. And I just want to talk about the pros and cons of where people are deploying authentication services and kind of the effects that those have on networks, and then talk about one specific use case that's a little bit unique. So here's a shaken deployment that's done at the switch. And what I'm kind of, with this network I'm showing is you've got some calling party. And again, this is an all SIP network. And that calling party, let's say it's hosted PBX in this case, or it could be a trunk as well, but in this case we'll say it's hosted PBX. They register with your switch through some ingress SBC, and then that call leaves your network through some egress SBC, goes out to the SIP network, whoever else that is that you have peering relationships with. A very common deployment that we see is this switch level deployment. And there's some advantages and then there's some disadvantages to this. So from an advantage side, the switch is generally where most people do a lot of their subscriber management. It's where if someone is spoofing or not spoofing. Okay, this calling party is using a number that I gave them, or they're not. A lot of switches are now getting configured a little bit differently than they historically have, where carriers are actually preventing customers from spoofing to simplify management. They say, I've given them these 5 DIDs. If they use something different, I reject the call. I don't let them make outbound calls. You could, of course, sign it at station B instead of that. But a lot of carriers are choosing to just not allow that to happen because, signing it at station B, from a carrier perspective, you're not going to get in trouble, but people might say, okay, that's a spammer. They need to stop making phone calls, and then you need to shut down that enterprise. It's maybe easier to just prevent them in the first place than having to have that happen after the fact. But that's all, local policy. You guys can decide whatever you want to do there. But this deployment is nice because this tends to be a nice point of management. Well, one of the downsides to this is you sign every single call, even those calls that go right back to another subscriber hanging off of that switch, or you can, depending on how you integrate the switch. And that can be inefficient from a cryptography standpoint. While it's not a big deal by any means, signing a call does have some cryptography in it. And the math associated with that cryptography is much more complex than the basic handling of a phone call. There's a lot of operations involved there, so it can put a bigger load on that authentication service the more calls that you have. So that's kind of one of the downsides here. You also have to be careful to make sure you authenticate the call at the switch and then verify the call at the switch, or where you place your verification matters, because again, those on-net calls kind of have a funny scenario where they don't go out to the SIP network like we're talking here. They actually go right back to a subscriber, and there could be some things to think about there. So this is a very common deployment because it generally does pretty well. But again, it does have some things you have to be very careful about, particularly on net calls. This is definitely a far less common deployment that we see, but it is something, depending on how your network looks, that I've definitely seen a fair number of people do. So in this scenario, what we're showing is that the calls are actually signed as they leave a carrier's network. Now, the big thing that people like about this is you only sign calls that are leaving your network. You're not signing on net calls, and that's good and bad. You don't want to waste that cryptography, but you also don't want calls that come from another carrier into your network to look verified, but when it's one of your own subscribers to a different subscriber, it doesn't look verified. That's not good. But I'll talk about how people are solving that a little bit later today, and then also actually next month there's some other techniques you can use. But this deployment has some advantages there. There's also some potential issues with this deployment depending on where you're doing your routing. Or actually, I say it's issues, but it actually can be both an issue and a benefit. So where this comes down to is failover. If you're, let's say you have a call, again, I think it helps if I use real world examples. So AT&T, they make a phone call, they send it to Verizon, and for whatever reason, Verizon can't accept that call, so they send it to Sprint. I know these are not transit providers, that doesn't make a lot of sense, but just kind of give names to make it simple. What do you want to happen from a signature standpoint? Should the first call have been signed, and then should the second call be signed again, or should it be reusing that same signature on both of those calls? I say both calls. It's the same call. It's just a reattempt on a different provider. And this can have some implications to that. If your call comes out of your switch, goes to the egress SBC, is signed, and then goes to the SIP, out to the SIP network, they fail the call, it goes all the way back to your switch. And then that whole process happens again, but to a different provider over here, then you've signed that call twice. Now, obviously, that's a waste of resources, but the advantage of that is there's now a new timestamp, a new fresh timestamp on that signature or on that token that was created. Now, if you do your routing at your egress SBC, the call leaves your switch, goes to the egress SBC, comes up as signed, and then goes out to the carrier A, it fails, comes back here, goes to carrier B. It's not signed again because it never goes back to the switch, never goes to the authentication service again. Obviously, that reduces resources, but if you have 5, 10 failures, unlikely, but definitely happens in some scenarios, that could take 30 seconds, even maybe. I've seen some long PDDs there. That can have an implication for the fact that that token, by the time it reaches the terminating service provider, could be stale if you signed it 30, 45, 60 seconds ago. In general, most verification services are going to use 60 seconds. But a lot of people want to lower those time limits down as low as they can, and these types of scenarios have an effect on that. So that's something to consider. Now, from the last call flow, I want to mention kind of a unique setup that I know some of the bigger wireless carriers are doing, if not most of the bigger wireless carriers. Just from an network optimization standpoint, this is kind of a clever way of deploying this. This is not in any way documented in any of the standards. So again, kind of looking at this, you've got the calling party, the ingress SBC, switch, and egress SBC. And what they've actually done is they've broken the authentication service into two sections, two portions. One of them is tagging the calls. It's setting what the attestation level should be, what that orig ID should be. And then the other function is actually signing it. In setting the attestation level, setting the orig ID has no cryptography. It's very low from a resource utilization. It's actually signing the call that has all the higher resource utilization. So a call comes into the switch, they tag that call, typically using P headers. There's a 3GPP standard for the headers that are used, but you kind of do this however you wanted to. And that call is tagged with the origination ID and the attestation value. And then if it leaves your network, it goes to the egress SBC, and the egress SBC has, I'll call it a dumb authentication service hanging off of it. It just gets a call from the egress SBC and signs it as that tagging that's on the call tells it to do. It doesn't know how to handle a call. It's just signing it the way the tagging says to. So from an egress perspective, not a lot changes. But what's nice about this model is for on-net calls, a call that comes from the calling party ingress SBC switch and then goes back out to another subscriber on your network. You never hit this authentication service with the cryptography. You just tag the call. And one of the things, and I'll talk a lot more about this when we talk about verification, that these tagging services are doing is they're actually both tagging the call for authentication and they're pretending that the call was verified for use within the network, so that the call, if it leaves the switch, goes to another subscriber, it actually looks like it was verified. And again, I'll talk more about how that verification looks and how that works when we talk about verification. But this method has been deployed by a number of the big wireless carriers, if not all of them. All of the deployments that I know of on the big wireless carriers are all look like this. It's a very efficient way of doing things. Doesn't fit for every network though. Tends to be more deployed in IMS networks. Now that's really what I wanted to talk about from a shaken authentication standpoint. Obviously, there's a lot more complexity that we didn't get into, but that's kind of the 10,000-foot overview of what shaken authentication looks like. And we wanted to stop here and answer any questions about the regulatory news. Donald can answer those, or anything about shaken authentication. I'd be happy to answer those. Any questions?
Feel free to use the chat if you don't want to speak out.
I guess we'll take this as a good sign we went through it thoroughly. Well, if you do have any questions after the fact, think of something later, want to talk about anything, feel free to contact us at the information provided here. Our website, transnexus.com, info@transnexus.com, or our main phone number here, and we'll get you to someone who can answer those questions, whatever your question may be. We do have a bunch of blog posts on our website. Sorry, not blog posts. We do have a lot of blog posts, but we also have a lot of white papers that go into deep dives about various topics related to Shaken and other services that we have for toll fraud, and actually quite a few white papers there. Check those out. And I will talk to everybody next month, where we'll do a deep dive in verification and give you any new news that's come up in the last month.
Okay, thank you so much, Donald. Thank you, Alec. Thank you, everybody. I am just going